In this video, we're going to continue talking about the common misconceptions and errors made in AP Calculus AB and Calculus AB in general. One of the mistakes that's easily made is leaving out the constant of integration, the plus c. In indefinite integrals, if you leave out the constant of integration on the AP exam or in class exams, most probably it's going to be marked wrong. If we have the indefinite integral of x squared dx, it does not equal x cubed over 3. Rather, it's equal to x cubed over 3 plus c. Same thing over here. If you have integral of e to the x dx, it does not just equal e to the x. Rather, it equals e to the x plus c. One more time, if we have integral of 1 over x dx, it does not just equal natural log of absolute value of x. Rather, it equals natural log of absolute value of x plus c. Remember to always tack that c on at the end if it's an indefinite integral. While we're talking about natural log of absolute value of x, let's address another common error. The integral of 1 over x dx is equal to natural log of absolute value of x plus c. So can we assume that integral of 1 over f of x dx is equal to the natural log of absolute value of f of x plus c? No, we can't. Actually, the integral of f prime of x over f of x dx is equal to the natural log of absolute value of f of x plus c. Now, why is that? Why is that we have integral of 1 over x dx, and that works out to be natural log of absolute value of x plus c, but when we have integral of f prime of x over f of x, that works out to be the natural log of absolute value of f of x plus c. Well, if you look at this, the denominator, let's consider the denominator as f of x. Then the top is the derivative of that. So over here we actually do have f prime of x over f of x. So it's essentially the same thing. But the more correct way of looking at it would be f prime of x over f of x, as opposed to just thinking there's a 1 over the denominator all the time. So let's say, for example, we had something a little bit more complex. Integral of 3x squared over x cubed plus 3 dx. That works out to be natural log of absolute value of x cubed plus 3 plus c. Because if you look at the top and if you look at the bottom, the top is the derivative of the bottom. The derivative of x cubed plus 3 works out to be 3x squared. So we have f prime of x over f of x, and that is natural log of absolute value of f of x plus c. Don't forget the plus c. Another common source of error comes from the chain rule. A lot of them are just careless mistakes. Sometimes it's hard to keep track of all the components of the problem, so we might make mistakes. So let's say we have the first derivative being equal to x squared times y cubed. I would be wrong to just say that, let's take the x term first. The derivative of x squared is 2x and the y cubed just stays. Now, if we're deriving the y, to just say that the x squared stays and the 3 comes down, so that's 3x squared, and then subtract 1 from the exponent, so y squared. So can we say that the second derivative of this term is 2x y cubed plus 3x squared y squared? No, we can't, because the first part is correct, but when we're deriving the y with respect to x, at the end we must write dy over dx to show that we're deriving y with respect to x. If you don't put this, then the second derivative is wrong. If you're deriving y with respect to x, always remember to put that dy over dx when you're deriving the y. Hey guys, Before I end the video, I just wanted to point out a few more things that to be careful of on the AP exam, or any exam really. When you're justifying your answers, you don't want to use ambiguous terms like it or they, because the readers or the graders may not know what it is referring to. For example, you don't want to say when it is 0, there is a relative minimum. What is it, and when is there a relative minimum? Rather, you'd want to see something like when x equals 0, the function f of x has a relative minimum. The readers know exactly when there's a relative minimum, and now we know what it is referring to. Another thing to be careful of is you want to show your setup even if you are showing answers from a calculator. So the readers or the graders necessarily won't assume that you have the correct setup just because you give an answer that is correct without showing any work. You want to at least show the setup. For example, if you're looking for the integral of x squared with respect to x, you don't just want to write the answer. You want to write how you set up the integral and then give the answer from the calculator. Those are some simple things to be careful of, but they can get you sometimes, and sometimes 1 or 2 points can be the difference between a grade or a 4 or 5 or 3 or 4 on the AP exam. So you really want to be careful of every little detail that you possibly can. So best of luck to everyone that's going to be taking AP or taking calculus. And if you haven't already, subscribe, share this video with anyone who's going to find it useful, leave a like, and I'll see you guys next time.